Well, hello, my name is Ayush Kumaja. Today I'm presenting my project predicting diabetes for the subject data mining. I, along with my friend Himanshu Rawat, we made this project. Basically, diabetes is a chronic disease that affects millions of people worldwide. It is caused by the body's inability to produce or use insulin effectively, which generally results in high blood sugar levels. So, early detection and timely management of diabetes is very helpful. So, yeah, so the machine learning algorithm can be used to predict the risk of developing diabetes. And in this project, we will aim to successfully predict whether a person has diabetes or not using a few ML algorithms like logistic regression, decision tree, random forest classifier, and high pace algorithm. And we will be having an outcome of 0 and 1, and we will be model tuning it for a better accuracy. So yeah. So the dataset used in this project is taken from Kaggle and was originally contributed by the National Institute of Diabetes, Digestive and Kidney Diseases. So here we have in this file we have some dataset attributes like pregnancy, glucose, blood sugar, and skin thickness, insulin, BMI, and these. I will mention the Kaggle link in the description. So here we are importing some necessary libraries. So due to the consignment of the project, I've already downloaded the here are some of the attributes which I already mentioned. We'll be checking the data right now. These are the data set in the CSV file, the diabetes or CSV, which we downloaded from the Kaggle. Now we will be preparing data. So first we will be calculating the missing values on the skin thickness column and insulin column. So if you can see, they are like skin thickness and insulin have some zero columns which have some zero values. And initially we are like reading the data, so we don't want zeros in and blank in insulin and skin thickness column. And we can predict something from this table. Like if you see pregnancy 618, so we can actually classify the gender with these data. So but once we ran it, we can see the number of missing values is 227 in skin thickness and insulin have 374. We will replace it with the mean of the whole data set of that column. So yeah, run it. And now we will see like how many zeros are left. So since we replaced with a mean, it should return a zero, and it is returning a zero. And we will be checking the display, and we can see those columns which were initially zero now are have the mean of the column. Right, we can totally see it. Now we will store some of the data in the. We will see the total number of records and the number of people who are diagnosed using the outcomes column, which you can see here like a 1 0. 1 means the person have diabetes and 0 means the person doesn't have diabetes. Right? So we can see the number of person diagnosed with diabetes and those who are not are already mentioned, and the percentage of the people who are not diabetic right now. Correct. So let's move on. We will basically split the data, and in the outcome column, we will have the target variable, and the feature will be just of the elements, rest of the columns which are not outcome. So here, the outcome column is this, and which is the target column, and rest of the data except outcomes is stored in the features. And we are just plotting the skewness. As we can see, the skewness is pretty high, so we will be using the logarithmics function right now. We can see it here. We are using, sorry, I just forgot to run some. Yeah, so once we run it, we can see this skewness, which is pretty high right now. And we will be using logarithmic function to reduce the skewness, and you can see. So we will be using a min-max scaler. So we will be defaulting the insulin, skin thickness, and diabetes function with a default value between 0 and 1. So initially you have seen the value was like 79, 78, 76, something like that. But now we want to concise it and make it from 0 to 1. And you can see it, and we are displaying the top 5 headers here. And you can see skin thickness, insulin, and their diabetes predictive function all are between 0 and 1. Now so here we will be doing training and testing data sets. So in X-train and Y-train, we will put that in features final, and X-test and Y-test we will put in outcome R. And the test size equal to 0.2, that mentions if the test size is 20% of the training set. And here we'll be printing the training set and the testing set. So for evaluation of the model, we will be using a logistic decision, random, and naive. So here we'll be creating and training our predicting pipeline. So X-train have the feature training set and Y-train have the feature sorry, income trainings. So here X-train have the feature training set and Y-train have income training set. And same for X test and Y test. We will be fitting the learner to the training data set. So here we are storing the time function and the end time function, and we are training the learner and the prediction test and train value. And we are computing the accuracy for the first 300 data set. And why we are doing it for the only top 300 training data set? Because in unsupervised learning, identifying the feature that have the strongest predictive power is a critical task. And when analyzing data sets such as census data we are working with, by narrowing our focus to a small set of keys feature that are most closely related to the target label, we can simplify our understanding of the underlying pattern and relationship in the data, and we can focus more on the data side of it. And we are doing same here. Here we are just importing the logistic and using our model logistic random decision tree. And here we are dividing our data into three sets, as I said earlier, into because we wanted to focus on a small data set. So you can see in the output also that logistic using is trained on 614 samples, and 10% of it is 61, and then 1% is 6. And similar for the random forest and ADA boost classifier. And here we are importing matplot library, and we are evaluating the result accuracy and the F1 score. So what result accuracy and F1 is, we will be seeing it later in the video. And this is simple matplotlib implementation. So here we can check the accuracy score of which is 0.34, which is 34%, and the F1 score, which is 40%, which is currently very less according to the data we are working. Since working with medicine stuff, we want some high accuracy ML models. So we'll be fine tuning, model training it even further. But here, what we can say is random forest classifier outperforms every other models like logistic regression and boost classifier. Like you can check it here. Like the random classifier is outperforming in every single one. Now we will be model tuning it. So model tuning involves adjusting the hyperparameters of the machine learning models to improve its performance. It is a critical step in the machine learning pipeline that can significantly impact the accuracy and efficiency of our model. And we are setting our parameters here, and we can check the accuracy of for our optimized and unoptimized model for the random forest. And why we are using random forest, it outperform all the other models right here. But we can like try to improve it more. So we will changing it. Like let's try 4, 5, 2, 4, 6, 8, and 10, and max that. Let's change it to 10, 20, 30. Let's model tune it and let's see what's does that. And after changing our parameters, are we able to achieve more accuracy? It is it happening. Let's try something. Let's try 1, 3, 5, 7, 9, and here we can use it to 4, 6, 8, and 10. Let's check the model tuning of it. Yeah, so yeah, it is not performing that much, but yeah, you can sole purpose was like you can change the hyperparameters and so as to increase the accuracy, which is our sole purpose in this model, and we will try to use it. And here we can see the top three most relative feature of our ML model in the argument section. So here we can see age, BMI, and glucose is the major factor for determining the if a person have a diabetes or not. So yeah, we can change it. If let's see for the top five people, top five attributes. So, yeah, try running it. There is some error. Oh wait. Yeah, now we can see the top five features and attributes which are more im- which is more important to determine if a person have a diabetes or not, which are insulin, pulmonary function, age, BMI, and glucose. Let's move on. So feature selection. So what feature selection does is using a subset of available features in the data, we can like, significantly reduce the training and prediction time of a model, which is very what we want. But it may also affect the model's performance by analyzing the feature importance, we can identify the top contributing feature and focus on using them for the training of our model. So we have already determined which are the top performing attributes. So we will using them for our purposes, and we can see the accuracy F score of our model. So if we compare it with the initial accuracy and F score, we have significantly increased it by model tuning it. And the last thing which was left was I forgot to explain what accuracy, F score, and precision and recall is. So what accuracy is, it is the number of correct prediction by the total number of prediction, and it gives us a percentage. And then confuse this concept known as confusion matrix. So in confusion matrix, we have four attributes as true positive, true negative, false positive, false negative. When both the actual and predictive values are one, true negative when both the actual and predictive values are zero, and false positive when the actual value is zero but the predictive value is one, and Fn when the actual value is one but the predictive value is zero. And what precision is? It is true positive by true TP by TP plus FP. And what we call is it is true positive by true positive plus false negative. And for TAF1, it is true into precision into recall divided by precision plus recall. And basically, F1 provides the balance between the precision and recall. You can check it out here. I will be mentioning all of these in the description. And this is the archaical data set. I'll be mentioning this CSV file in the description. And you can, at last, I will just show this is our accuracy for our testing and training data. And we have fine tuned it from 0.34, which is 34% accuracy, to 74% accuracy by changing the hyperparameters. So this was all about our project. Thank you for watching. Thank you very much.